In this video, we're going to be talking about the glassy transition temperature for polymers. So as you recall, a polymer is something that is made out of long chains of different molecules. You can see my other video if you need more information on what that is, but for you to get a gist of it, it generally looks like a bowl of spaghetti with long chains of molecules. Most polymers are amorphous, meaning that they don't have a crystalline structure. However, you can have a semi-crystalline polymer. That would look something like this and would have regions of crystallinity inside, like that. So the glassy transition temperature, which is what we're talking about today, only is influenced by the amorphous region. This is because in the amorphous region, again, if we have our bowl of spaghetti, the strands can slide in between each other when they are allowed to, and this is what causes a plastic to become rubbery. So what is the glassy transition temperature? The glassy transition temperature is the point at which a hard, solid polymer, or think plastic and rubber, becomes rubbery. And this influences the elasticity, the strength, and the tensile strength of this material. So if we look at a graph of the temperature, this can be in Kelvin or Celsius, and the stiffness, or modulus, in some unit of pascals. Generally, what this curve is going to look like for a polymer is going to be something like this. You're going to have the glassy region here. It'll dip down, rubbery, and then it'll dip down again. So here we have our glassy region, and this is our rubbery region. And eventually, as it falls down this way, it will hit liquid or melted plastic. So the point at which the transition temperature is right, glassy transition temperature is right in here. Again, this is the point in which the polymer is considered to be going from glassy to rubbery. And that's going to happen at a range of temperatures. And this range at which this can happen for most synthetic polymers is all the way from 170 to 500 degrees Kelvin. So that's a huge range. What that is in Celsius is about negative 105 to about 225, which again is a super big range. This is why sometimes you see a polymer or a plastic and it is hard at room temperature. It's because its glassy transition temperature does not fall in this range, while some other polymers are rubbery at room temperature. Again, this range is just really big. And this glassy transition temperature will move depending on the mobility of the polymer chain. So these chains we have over here, how easily they're able to move will change depending on their weight, their size, and how, again, the temperature that they are at. So that is the glassy transition temperature. One other thing to note is that like most materials, as a polymer goes down in volume and changes different phases, or as it goes down in temperature and changes different phases, the volume will also change. So if we have a temperature versus specific volume plot here, it's generally going to look something like this for a polymer, again with glassy being here. Our rubbery portion is going to stretch up here, and then liquid is up here. So that is why the melting temperature and the glassy transition temperature, so TG, this is our TG, the melting temperature and the glassy transition temperature are different for a polymer. One allows the molecule strands to move a little bit, whereas a melted polymer or liquid is free moving molecular strands. Check out my other videos to see the relationships between molecular weight and glassy transition temperature and some other influencing factors.